Hello everyone, in this video we are going to do the practice problems that you have to glue in your notebook. So this is the glue-in that you have. So you will put glue on this side and then do the problems and then fold it like this and put that in your notebook. Okay, so let's do the problems on this practice handout. So how do we do the problems based on the heating and cooling curves of water? So just a quick review. You should know all the points. What is A, what is B, what is the phase at point B, C, D, E and F. And then you should be able to solve for different heats. So you have to take one line segment at a time and solve the amount of heat energy absorbed or released at that point, these two points, right? And then for the total energy absorbed, you have to add all of those. Okay. So just remember, at the phase change, that is B to C, the amount of energy absorbed is Q2. That is always equal to ml because the delta T is 0. There's no temperature change, so there's no delta T. So we cannot use Q equals mcat from B to C or D to E. Instead, for all the phase changes, we will use ml. Okay. With that, let's start. So this is how you have to do your worksheet 6. All the questions on worksheet 6, you have to draw the graph, label the starting point and the ending point, and then solve. So the first question is, what is the energy needed to melt 326 grams of ice and heat it to 100 degrees Celsius? Now, what is the information given to us? We are starting at ice. We have 326 grams of ice, right? So the mass is 326 grams. Now, since we do not know the initial temperature of the ice, it means we are starting at 0 degrees Celsius, right? So if you are not given the temperature of ice, it means we are starting at B, because water turns into ice at 0 degrees Celsius. So the temperature of the ice is taken as 0 degrees Celsius. So we are starting at point B. So you will label point B. So this is point B. This is where you are starting. Now we are heating the ice to 100 degrees Celsius. So that is our end point. Now where do we see 100 degrees Celsius? So we start at point B. This is 0 degree, water at 0 degree, and this is point D. This is water at 100 degrees Celsius, right? So we are going to go from B to D. So this is 100 degrees Celsius. And we are starting at 0 degrees Celsius. Okay. So we have to go from B to D. How? We cannot just go directly to D, right? We have to go through C. So first you will go to C and then from C to D. So now this is a temperature change. So remember, this one was Q2. So you are solving for Q2 and then you are solving for Q3. So Q2 is a phase change, B to C. Look, B to C is phase change. So that is Q2. We will use M times latent heat of fusion from going to C from B. Okay. So let's write down the equation. So Q is ml. Since this phase change is melting, we're going to use L fusion. Okay. And then Q3, this is Q3. Going from C to D is Q3. C to D is Q3. Since the temperature changes from 0 to 100, Q3 is MCAT. At C we have water, at D we have water. So we're going to use the specific heat of water here when we are using MCAT. So Q3 is MCAT with specific heat of water. Delta T changes. Right? Now let's plug in the values. So we get, now look at the chart that is given to you. Latent heat of fusion of ice is 334. Since we are heating is endothermic, so L will have a positive sign. When we are cooling, then it's an exothermic, heat is given out, then L should be taken as negative. So let's plug in the values. So M is 326 grams and latent heat of fusion is 334 joules per gram. So that would be joules over grams. So grams and grams cancel. If you solve that, you are going to get this number here. Okay. Now let's solve for Q equals MCAT. So plug in the numbers. 326 grams times specific heat of water is 4.18 joules over gram times Celsius, and then delta T, since we are starting at 0 degrees Celsius, so what is C? C to D is 0 degrees Celsius water to water at 100 degrees Celsius, right? So this would be 100 degrees minus 0 degree Celsius. So you can see Celsius cancels, grams cancel, you get answer in joules again. So this is equal to this number right here. Now the total amount of heat that was absorbed is Q2 plus Q3. So Q2 plus Q3 comes out to be this. Okay. Let's do the second question. Determine the energy required to convert 21.1 grams of ice at minus 6 degrees Celsius. So now we have the temperature of the ice. We are starting at ice at negative 6 degrees Celsius. So that would be point. So less than 0 is point A, right? So we are starting at point A and we are going to steam at 100 degrees Celsius. So now at point D we have liquid water at 100, but we are going to steam at 100 degrees Celsius. So this means we are going to point E, from A to E. Okay? So we are going from point A to E. Okay? So this is point A, which is negative 6 degrees Celsius. We will go to point B, then to C, then to D, then to E. That is where we stop. Okay. So we are going to use Q1, Q2, Q3 and Q4. So Q1, 2, 3 and 4. Okay. Remember, Q1 and Q3 are MCAT because the temperature changes, right? Whereas Q2 and Q4 are phase changes, temperature does not change, so we have to use ML. Okay. So let's plug in the numbers. So Q equals Q1 equals MCAT. Here, since at A and B we have ice, so we are going to use specific heat of the ice here times delta T. So let's plug in the numbers. So we have 21.1 grams of ice. Then specific heat of ice is 2.09 joules over grams per Celsius. And then delta T, since we start at -6 from A to B, so this is A to B. We are going from -6, that is the initial temperature, and the final temperature is 0. So delta T would be 0 minus -6. So that would be a positive 6 degrees Celsius. Okay. And when you solve, you are going to get this number right here. So Q2, this is Q2. This is a phase change. Since it's melting, we're going to use ML fusion. So M is 21.1 grams, and latent heat of fusion of ice is 334 joules per gram. So that would be 334 joules over grams. Okay. And when you solve that, you will get this number right here. Now Q3, again the temperature changes, C to D. So this is C to D. This is B to C. So we are going to use MCAT. Now since at C and D we have liquid water, so we are going to use the specific heat of water, right, times delta T, and then this is equal to 21.1 grams times 4.18 joules over grams Celsius times delta T. Now since the delta T final temperature is 100 at D and at C it was 0, so that would be 100 minus 0 degrees Celsius, and you get this number right here. Now again we are at the phase change, so D to E is a phase change, that is Q4. But since at D we have liquid water, we are going from liquid water to steam, right? So we have to use M times L of vaporization of water. So mass is 21.1 grams, and latent heat of vaporization of water is 2260 joules per gram. So 2260 joules over grams, right? And if you solve that, you are going to get this. So Q total would be the sum of all of these, and you get this answer. Let's do one more. So this time we are going to do a cooling curve. So what is the heat transfer involved when you convert 51 grams of water at 0 degrees Celsius to ice at minus 20.3 degrees Celsius? Now we are at water at 0 degrees Celsius. What point would that be? So water at 0 degrees Celsius is point C. So we are right here. So this is water at 0 degrees Celsius, and we are going to ice at some negative temperature. So we are going from C to A. Okay. So we are going from C, point C. This is where we are at. We are going to the point A through B. So we are going from C to point A. We are at water and we are going to ice. Right? So how do we go from here to here? Remember, C to B is Q2, and B to A is Q1. Okay. So when we are going from C to B, we are cooling the water to make ice at 0 degrees Celsius. So we're going to use M times L fusion. But since we are cooling, this is an exothermic reaction, we are going to use the negative sign for latent heat of fusion. Because when you cool something, cooling is, or freezing is an exothermic reaction. So this is an exothermic reaction. So you have to use a negative sign with latent heat of fusion. Okay. So this would be, mass is 51 grams and the latent heat of fusion would be negative 334 joules over grams. So when you solve this, you're gonna get this number. Now this was going from C to B. That was the phase change. Now let's solve for Q1. So Q1 is going from B to A. Right? So we are going to go from B to A. So we're going to use MCAT. C would be for ice, because at point B we have ice and at point A we have ice. Right? So let's plug in the numbers. Mass is 51 grams. Specific heat of ice is 2.09. So let's write that down. 2.09 joules over gram Celsius. And delta T. Now here's the tricky part. So you are at point B, which is 0 degrees Celsius, right? That is the initial temperature. And you are going to negative 20.3, that is your final temperature. So this is TF. This is 0 degrees Celsius ice is T initial. So you will get final negative 20.3 minus 0. And when you solve that, you will get negative 2163.78. And then for Q total, you have to add Q1 and Q2 and you get your answer. The last one, what is the energy absorbed when you melt 75 grams of ice at -5? So again, we are starting at A. So you start with ice at -5 degrees Celsius, right? And you are heating it to water at 90. So you will convert ice to ice at 0 degree. Then ice to water at 0 degree. And then you're going to heat the water to 90 degrees. So we are going from A to B to C, and D is 100, but we are not going to 100, but we are still heating the water. So our D will be little lower than 100 degrees mark, right? So Q1, this is MCAT, where we use the ice specific heat, and Q2 would be ML fusion, since we are heating, so no need of negative sign, and Q3 will be MCAT again with C of water, right? So Q1 would be mass is 75, specific heat of ice is 2.09 joules gram Celsius, and delta T would be, we are starting with -5 and we are going to 0. So 0 minus -5, right? And then when you solve that, you are going to get this number here, right? And then again, Q2 is 75 grams. Latent heat of fusion of ice is 334 joules over grams. And when you solve, you're going to get this. Then Q3, MCAT again. So 75 grams. C of water is 4.18. Now delta T would be, the final temperature is 90 and the initial temperature is 0, right? And when you solve this, you get this, and then you add up all the individual amount of heats and you get the total amount of heat absorbed. Okay, hope that video is helpful.